Can now come to another problem based on time scaling, time shifting on concept. Now the problem that is 1.7. This problem is quite different from previously discussed 1.5 and 1.6. The only criteria was the time expansion, but here there is along with the time expansion there is also a time shifting is also going to take place. Now we are going to read the problem. Figure 7.1.7a shows a staircase like signals x of t that may be viewed as a 4 rectangular pulses starting with the rectangular pulse g of t shown in the figure 1.7b. Construct this waveform and express x of t in terms of g of t. Okay. See in this term, okay, we know that x of t is superimposed of 4 rectangular pulses. Say this is one rectangular pulse, another rectangular, okay, this 4 rectangular pulse with a different width size. Okay, I'll call this as an g1 of t g1 of t, that is this signal separately, and g2 of t this signal it has been written, that is from +1 to +4. Okay, similarly g3 of t, that is from 2 to 4, and g4 of t, that is from 3 to 4. Okay, I have split this x of t in different form: g1 of t, g2 of t, g3 of t, and g4 of t. So this is some quite different problem, so that it consider both by g of t, that is -1 to +1 is there. My x of t is completely is from 0 onwards, mean that this g of t is shifted along with the expanded. So what we do here is we will consider one equation, that is g of at minus b. G of at minus b, what has been shown, where a, the coefficient of t, that a is a time scaling factor and b is the time shifting factor. We know that while discussing upon the operation performed on time dependent variable, we come across that the coefficient of t, that is time scaling factor, and b is a time shifting factor. Okay, first now we have to determine these values a as well as the values b. Now we will compare g1 of t. We will first start with the g1 of t. We will compare this g1 of t with g of t. By comparing that, we can see that the pulse width of g of t is 2, whereas the pulse width of g1 of t is 4. With this, it means that g1 of t is expanded than that of the g of t. g1 of t is expanded than not that of the g of t. By what factor? See, g of t is 2 and g1 of t is 4. This means that by observation only, you come that the expansion is 2 times. Expansion is 2 times. So that the expansion factor should be written in terms of, that is a is equal to, I have to write this as 1 by 2. Expansion should be written in terms of 1 by 2, and compression should be written in terms of 2, 3 and 4, and like that. So with this, a value is 1 by 2. Next thing, we have to find the value of b. Find the value of okay, to find b, we see the midpoint of g of t, the previous problem, the diagram. The midpoint of g of t is 0, -1, +1. This is g of t. And similarly, the midpoint of g1 of t is 2. The midpoint of the midpoint of g of t is 0, whereas the midpoint of g1 of t is at 2. Hence, we must choose b to satisfy the condition, that is a of midpoint of g1 of t minus b is equal to 0. You see this equation. What is the midpoint of g1 of t? That is 2. And so that I substitute that to a of 2 minus b is equal to 0. Okay. A of 0. So that b is equal to a into 2. Just now in the previous calculation we found that the value of a. So that a is equal to 1 by 2. Substituting that a is equal to 1 by 2 and we will get b is equal to 1. This equation is good. So I can express this g1 of t as g of at minus b. That is g of at minus b. The value of a is 1 by 2 and the value of b is 1. With this we get g1 of t. This is not the complete. Just we have found the g1 of t. Now we have to similarly we have to find the g2 of t from the g of t. Again consider the same equation, that is time expansion shifting equation, that is g of at minus b. To find a, the pulse width of g of t is 2. Okay, same that the g of t is 2, whereas the pulse width of g2 of t is 3. Okay, the pulse width of g2 of t is 3. Thus we need to expand g of t by a factor of 3 by 2. Means we need to expand the factor of 3 by 2, or we can call it as the expansion is 1.5 times, or 1.5 times we can express it as 3 by 2. Hence a is equal to, okay, we have to take the reciprocal of that value, so that a of 1 by 3 by 2, a is equal to 1 by 3 by 2 can be written as a is equal to 2 by 3. We found the value of a is equal to 2 by 3 as shown here. Okay. Similarly, we need to find the b. The midpoint of g of t is 0, whereas midpoint of g2 of t is 2.5. Comparing g2 of t and g of t, that is 0 and this is 2.5. The 2.5 can be written as 5 by 2. Hence, we must choose to satisfy the condition, that is this equation. A of midpoint of g2 of t minus b is equal to 0. So, a of 5 by 2 minus b is equal to 0. With this, we find the value of b. By substituting the a value 2 by 3, we get b is equal to 5 by 3. So, we get g2 of t in terms of g of t, that is g of 2 by 3 t minus 5 by 3. Okay, similarly, now we have to generate g3 of t. Okay, again the same procedure, g of at minus b. The midpoint of g of t is 2, whereas the midpoint of g3 of t is also 2, means that there is no need of expansion or compression. Both are same. g3 of t is same as that of g of t. Okay. Okay. Now, okay. Anyhow, the time there is no expansion or compression, we will see that the shifted. A midpoint of g3 of t minus b is equal to 0. What is the midpoint of g3 of t? That is 3. So b is equal to a into 3, we will get 3. So g3 of t is equal to g of t minus 1, g of t minus 3. See, the coefficient of t is equal to 1, indicating that there is no expansion or compression. Minus 3 means the original signal g of t is shifted towards the right side by a factor of 3 times. Okay. Similarly, we need to find the g4 of t. Again, consider the same equation, g of at minus b, where a is the scaling factor and b is the shifting factor. The pulse width of g of t is 2, as usual. The g4 of t is 1. So, in earlier previous g3 of t there is no expansion, no compression, and g2 of t and g1 of t there was an expansion, but here g of t, my g4 of t is the compressed version of g of t. See, because why? G of t, the width is, pulse width of g of t is 2, whereas the pulse width of G4 of t is 1. The compression is by a factor of 2. So now is directly A is equal to 2. If it was expansion, I we supposed to write A is equal to 1 by 2. Since this is a compression, directly we write A is equal to 2. After that, we need to find the value of B. To find B, we will choose the midpoints. The midpoint of G of t is 0, whereas the midpoint of G4 of t is 3.5. 3.5 can be written as 7 by 2. 7 by 2 is nothing but 3.5. So A of midpoint of G4 of t minus B, this equation. Substituting that value, A value, and get B is equal to 7. So G4 of t is equal to, substituting the value of A and B, we get G of 2t minus 7. And adding that, my original signal, whatever the shown in the figure of 1.7a, x of t is the superposition of all the 4 signals, that is G1 of t plus G2 of t plus G3 of t plus G4 of t. Now representing the question asked is, I don't want any in terms of G1, G2, G3, I need directly in terms of G. So that substituting that values, x of t is equal to G of 1 by 2 t minus 1 plus whatever the we get the values of G1, G2, G3, substituting that we have written this equation. We get this solution.